Okay, radical equations are basically just equations that have radicals in them. What we're trying to do is to solve for x, like most all other equations that we're trying to deal with. So I've got a couple examples over here. Let's start with this one. Isolate the radical. What does that mean? That means get the radical all by itself on one side. So in this problem, well, if I look at it, the radical is by itself. There is no number on this side of the equal sign that is outside the radical. So I've already got that step. So now I have to ask myself, to solve for x, how do I get rid of that radical? Most of you can remember that when you see a minus 7, we're going to have to add 7 to get it over to the other side. Well, I can't do that yet, but I add 7 because it's the inverse, the opposite operation to subtracting. Well, I am taking the square root. What is the inverse or opposite operation to taking the square root? It's squaring. So what I'm going to do is I'm going to, step 1, square both sides. When I square both sides, a square cancels with a square root. Completely cancels. So all I have left is an x minus 7, and so I wrote that. On this side I have a 6 squared, which gives me a 36. And now you can add 7 to both sides. Why? It's the opposite operation. When I add 7 to both sides, what happens to the 7s? They cancel completely. Just like over here, the square and the square root cancel each other out. And so all I'm left with is an x equals 43. Let's try another one. Well, this one's a little different because it doesn't have just a square root symbol, it has a 3 here. But first thing I need to do is isolate the radical. Well, it's already isolated. There is no number outside the radical. So now I can do the next step, which is to get rid of a cube root. To get rid of a third root, I cube both sides. Raise both sides to the third power. The third power and the third root cancel each other out. And I am just left with 5x minus 2. On the right side, 2 to the third power, I can figure that out. 2 times 2 times 2 is 8. And now you would solve like any other problem that you're solving. I want to add 2 to both sides. The minus 2 and the plus 2 will cancel out, and I have 5x is equal to 10. Now, that's an x times a 5. The opposite operation is to divide by 5. So next I'm going to divide by 5. Divide both sides by 5. They cancel, and I have x equals 2. Let's try a couple from scratch. See if I can put this down without hitting myself over the head. All right, Let's see if I can reach. All right, this is trickier because I have to isolate the radical. It's not isolated right now. Outside this radical is a 6 and a minus 5. So I have to get rid of those. Well, you should probably get rid of the minus 5 first. I would highly recommend that. So the opposite of subtracting 5 is adding 5. So I'm going to add 5. Well, that's a 4. Brain, blurb. Add 5 to both sides. And I still have the 6 times the square root of x plus 3. The minus 5 and the plus 5 cancel. 37 and 5 is 42. Now what do? I have to get rid of the 6. That's a times 6. Opposite operation, divide by 6. When the 6's cancel, I have left square root of x plus 3 equals 7. Now I'm kind of back to where I was on these two problems. My radical is all by itself, and so to get rid of a square root, I square both sides. Now, squaring a square root cancels out, and I'm left with x plus 3. 7 squared is 49. Subtract 3 from both sides. X is 46. And you know you can plug these back in. 46 plus 3 is 49. What's the square root of 49? 7. 7 times 6 is 42. 42 take away 5 is 37. So we're right. All right, now this one is very different. You're very rarely going to see one like this. The problem is it has 2 radicals and this extra minus 2, which messes things up. Is one of my radicals isolated? Yes, it is, the one on the left. So what I have to do is square both sides. Now, the left side's fine. When you square a square root, they cancel, and I have 3x minus 3. But when I square the right side, I can't just square this and this and think I'm done. I have a binomial. I have 2 terms. I have to square 2 terms, means I have to write it twice. And then, lovely fun time, I have to use FOIL. So I'm just going to keep writing this over here. And here we go. We have to use FOIL. Let me put this orange one away. All right. The square root of 3x plus 13 times the square root of 3x plus 13 is just 3x plus 13. The square root of 3x plus 13 times negative 2 is a negative 2 times the square root of 3x plus 13. Inner, I'm doing first, outer, inner, last. First was these 2 multiplied and gave me 3x plus 13. Outer gave me this square root times the negative 2, which gave me this value. Now I have to do the inner terms. The inside terms are a negative 2 times the square root of 3x plus 13, which is another one of these. And then finally, last, the last term in each parentheses. Negative 2 times negative 2 is positive 4. Okay, I'm going to clean this up just a little. 3x minus 3 equals 3x. I have a 13 and a 4, which is a 17. And I also have a negative 2 square roots minus 2 square roots is a minus 4 square roots. And you can only do that because they're the exact same under the radical. I told you this is an ugly one, but you can do it. Just take each step one at a time. All right. I had 2 radicals. I isolated one of them. Once I did that, the rule is square both sides. Or if it's a cube root, you cube both sides. But it's square roots, so we're going to square both sides. Well, I did that, and guess what? I got rid of one of my radicals. I'm down to 1. So, since I had 2 of them, I'm going to have to do it again. Okay? So now we have to isolate this radical. Meaning, I've got to get this 3x out of here, this 17 out of here, and this times minus 4 out of here. So I have to isolate my radical again. Let's subtract 3x from both sides. Oh, looky here. Not only does it cancel here, it cancels here. That's a good thing. Promise. Negative 3 equals 17 minus 4 times the square root of 3x plus 13. All right, now I'm going to subtract 17 from both sides. And I get negative 20 equals negative 4. This is starting to look a little bit better. Some of you may be going, but it's a lot better than it was up here. All right, I have a times negative 4. To get rid of that, I need to divide by negative 4. Whoop. And negative 20 divided by negative 4 is a positive 5. And these negative 4's cancel. Whew. Am I done? Oh no, I'm not done yet, but I'm so close. Because all I have to do now, I have isolated the radical. It is all by itself on one side of the equal sign, so I can now square both sides. When I square both sides, on the left, 5 times 5, it's not 10, it's not 5 times 2, it's 5 to the second power, which is 5 times 5, or 25. When I square a square root, I have 3x plus 13. Subtract 13 from both sides. I get 12 equals 3x. Divide both sides by 3, and I have an answer. I could plug it in and just see if it works. 3 times 4 is 12, minus 3 is 9. This would be the square root of 9 equals 3 times 4 is 12, plus 13 is 25. What's the square root of 9? 3. What's the square root of 25? 5. 3 equals 5 minus 2. That's true. Yay. We did it. Will you have a bunch of these? No. Is it good to know how to do this? Yes. But just make sure you can at least do the first ones. That should help you. And good luck.